So today we're going to look at evaluating limits using the two more basic methods of substitution and factoring. So here we can see we want the limit as x approaches 2. So all I'm going to do is everywhere I see x, I'm going to replace it with the number 2. So I get negative 2 minus 2 as my numerator. At the bottom I'll have 2 squared plus 2 plus 1, and that's going to give me negative 4 on 4 plus 3, which is negative 4 on 7, and that is the answer. However, it's not always that straightforward. For example, if I try to substitute x equals 1 into each of my x values of the denominator, I'd end up with 0 because 1 minus 3 plus 2 gives me 0. And we all know that if we have 0 in the denominator, then the function becomes undefined. So we need to use factoring if this happens. In summary, if you substitute your x value into the denominator and it equals 0, then we need to use factoring. So let's go ahead and factor our denominator. It's a quadratic because it's to the power of 2. We're going to use the product and sum method, which means I want two factors of 2 that add up to negative 3. So my product is 2 and factors of 2 are 2 and 1. But I need a sum of negative 3, and 2 plus 1 doesn't give me negative 3, so this doesn't work. So I'm going to try the negative, because remember, if we have both negatives, we end up with a positive answer. So negative 2 times negative 1 is 2, and negative 2 minus 1 is negative 3, so that works. So my factored form in the denominator is going to be x minus 2 and x minus 1. So I've just rewritten that with the factored form as the denominator, and what you can see is that the x minus 1's cancel, so I'm going to end up just with negative 1 on the top over x minus 2, and then I can perform my substitution. So I'm going to substitute x equals 1 for my x value, and I end up with negative 1 over negative 1, which is equals 1. So the limit of this function as x approaches 1 is 1. Here is another example where you can see if you substitute x equals negative 2 here, we're going to end up with 0. And we can't have 0 in the denominator, so we need to revert to factoring. I'm going to factor the numerator using product sum method again. Our product is 6 and our sum is 5. So we need two factors of 6 that add up to 5, and they are 3 and 2. So it's going to be x plus 3 and x plus 2 in our numerator. As you can see, the x plus 2's cancel, so you're just left with x plus 3. And then we can substitute the negative 2 into our expression. So that equals negative 2 plus 3, which is again 1. Now you could be asked to graph this, and it is a continuous function, it's a linear equation. However, because of our denominator equating to 0, it doesn't exist when x equals negative 2. So what does that look like? So here we have the graph of the limit of our function, which we worked out to be x plus 3, as you can see on the graph. But you can see here that there's a discontinuity at negative 2, because if x is negative 2, then the denominator is 0. Now let's just say you've done the factoring, and you get to the stage where you're cancelling out, and you have your final numerator and denominator. If your substitution then still gives you 0 in your denominator, then a limit as x approaches negative 4 does not exist. I'll repeat. So if you go through and you've done your substitution, you get a denominator of 0, so you use factoring instead. If you still get a denominator of 0, there is no limit as it approaches that value.